Good morning, everyone, and thank you very much for, it's a pleasure to join this conversation. So the question was about the emotions, and my talk is going to be about emotion as the engine of misinformation. And I'll talk about social narratives to financial markets. This is where we start really in this slide. Every domain that we have studied, from health misinformation to political rumors and to financial hype, shows the same emotional fingerprint. Fake news carries more anger, fear, anxiety, and sadness more than real news. And rumors spread much further and longer when they evoke anticipation, anger, or trust. So when users feel high arousal emotions like fear, surprise, or disgust, the likelihood of resharing skyrockets. So our take is that emotions are not really a side effect of misinformation, but they're rather the mechanism. And yet most LLM systems treat emotions as mostly irrelevant. So our work showed exactly the opposite. So for the first part of our research agenda is really we asked, can we systematically map and model these affective signals? Oops, let me see. Okay, so this is where the family of emotional LLM starts. The MOLLM family is built for. These models give us emotion intensity, sentiment strength, valence, and multi-label emotional profiles. In other words, we have a high-dimensional emotional fingerprint for any piece of content. And this moves us beyond the lexical-based approaches and methods into more real and effective representation. The tasks we see here about emotion classification, intensity regression, valence scoring, let us quantify the emotional structure with precision. So once we make emotion computationally explicit, then we can reliably tell which content is likely to be rumor, which content is likely to be false or conspiratorial or manipulative across domains. And that's across any domain, from public health to finance, politics. So what we see here is the foundation. So we can measure emotion, we can model it, and we can use it. So once we do that, basically, we're looking at a specific type of misinformation. Conspiracy theories are a specific form of misinformation, and they're characterized by emotionally charged narratives that imply that we have hidden causes or secret actors, etc. But once we have effective representations, then we can start asking what distinguishes, say, for instance, conspiratorial content from everything else. And we can look at across different data sets, but again, we see the same pattern. On the left, we have the emotion intensity. So conspiratory content consistently shows higher anger and higher fear with very tighter peaks. So meaning the emotional signature is much more concentrated and more predictable. In the center, we see the categorical distribution. So conspiracy theories lean heavily on negative, on high arousal emotions, anger, fear, or disgust, and almost never, very rarely, on positive stakes like joy, love, or trust. And on the right, we see sentiment intensity, which shows the same split. Conspiracy narratives just don't lean negative. They lean intensely negative with higher peaks and sharper tails. So the takeaway for this kind of work is that conspiracy theories, which is a type of misinformation, are not just defined by what they claim, but by the emotional landscape and the emotional they inhabit. So this takes us to another work. Once we model emotional signals, our next challenge is how do we integrate these signals into a modern LLM so that it can actually detect conspiratorial content. And this led us to the CONSP-EMO LLM. It's an instruction-tuned model that learns to hear conspiratorial emotion. On the left, we see some of the tasks that it was trained on, identifying whether a text supports, say, a conspiracy, whether it refers to specific conspiratory categories, how closely it relates to a known conspiratory theme. And these tasks explicitly expose the model to the emotional and the narrative structure of conspiratorial language. So the catch, of course, of these fine-tuned models is that it's extremely strong with the conspiracy domain, but perhaps much less reliable once we move to new topics. So it shows us what is possible, but it also shows us the limitations that we have. And enter the last, perhaps, things that I would like to say here is about the more strong, the model of RA-MLLM. So we saw that in the conspiracy LLM, it's very good in domain-specific models, but we really wanted a system that could recognize misinformation across domains, health, politics, climate, finance. And this is where the RA-MLLM comes in. It's a retrieval augmented model, but not in the conventional semantic sense. So instead of retrieving text that looks similar, it retrieves text that feels similar in the sense we are looking at the index stores both semantic but also emotional embeddings, which I discussed before. So when we have a new post, RA-MLLM retrieves examples that share the same emotional structure. So you have fear and anger dynamics, sudden pessimism spikes, or high arousal and negativity. So those effectively basically matched examples become in context demonstrations for the inference model. So instead of fine-tuning per domain, RA-LLM performs cross-domain pattern matching based on emotional fingerprints. And how can we apply this into a real application? We applied these models to finance. Often we think that finance is described as a very rational and data-driven, so immune to emotional distortions that we find in other fields. But markets, of course, they're human systems, and the human systems also are basically profoundly emotional systems. That means that misinformation in finance is also very present. So the question we had is, can we build LLMs specifically to detect financial misinformation? And the FMD Llama is like the first open source model designed to do exactly that. It's built on Llama 3.1 and is trained on a multitask data set, which actually includes both short fact claims, like in FinFact, and also longer financial news style text, which actually are labeled as true or false. So together, these tasks give the model precision because we have the short specific claims and also the robustness on full narrative misinformation. And because unlike generic LLMs, which tend to hallucinate on specialized domains, the FMD Llama is trained to both classify but also explain, justify the decisions using financial reasoning. So to end up, my work is actually, this is where emotion, misinformation, and finance intersect. So the questions that you ask is a closing reflection about misinformation and emotion. across the different domains we looked at, we saw a single pattern, which is really very difficult to ignore, that misinformation is not begin with facts, with content. It begins with emotion. So it exploits high arousal states long before even it starts distorting the content. So all these emotional shifts shape what we pay attention to, what we remember, and ultimately is how we behave. So finance, the example I gave before, just exposes perhaps the consequences a bit faster. So you have the same emotional distortions that drive rumors in health or politics, but they can travel through markets and portfolios, etc. So the systems that we're building reflect this reality, emotion-aware models that can read the affective, basically, fingerprint of misinformation. And all of these points, basically, that I made come to the same conclusion. Misinformation is really not just an information problem. It's a behavioral as well, and a systemic one. And the challenge ahead for us is not detecting what is false, but understanding why it spreads and how it reshapes decision and how we destabilizing basically human and machine judgment. So therefore, emotion is at the core of this work. Thank you.